See, question number 6 is a very important question. For this, you should have the idea of inequality for increasing and decreasing function. Inequality rule, basically we have to study the rule of inequality, or you can say the inequality rule for an increasing and decreasing function. The rule is very simple. If, let us suppose, fx is an increasing function, the rule is, let us suppose fx is an increasing function, right? And for this fx function, let us suppose we have two values, x1 and x2, right? If x1 is greater than x2, now taking f both side, if you want to take this function both side, that is the f of x1 and f of x2, since f is an increasing function, there will be no change in inequality. Let us see an example. For example, tan x. Tan x is an increasing function, right? Tan x is an increasing function. See, 30 degree and 60 degree. What is the relation between 30 degree and 60 degree? 60 degree is greater than 30 degree, right? When you will take tan both side, tan 30 degree and tan 60 degree, still this relation will hold true. Why? Because tan x is an which type of function? Increasing function. Let us have you understood this concept? So whenever your function is increasing, and if you take that function both side, there will be no change in inequality. You can just do the reverse for an decreasing function. Let us suppose gx is an decreasing function, and let us suppose if x1 is greater than x2. Now if you take g both side, taking this function both side, it means we are discussing g of x1 and g of x2. The inequality will get reversed. Have you understood this? Let us take an example. Sin x is, cos x is an decreasing function. Let us suppose if cos x is a decreasing function. If cos x is a decreasing function, if you know that cos x is a decreasing function, let us suppose the same example, 30 degree and 60 degree. This relation is true for 30 degree and 60 degree, but if you take cos both side, cos 30 and cos 60, cos 30 is root 3 by 2 and cos 60 is 1 by 2, and it is clearly visual that this is root 3 by 2 is greater than 1 by 2. So inequality gets changed. Are you getting this point, Rishit?
Yeah.
Now, it means you should have the idea that which function is, if you are taking any function both side, for any inequality, you should have the knowledge that your function is increasing function or decreasing function for that case. Are you getting this point?
Yeah.
Now let us see some more concept behind this. Now let us suppose I have a function y is equals to sin x. Is it an increasing function or decreasing function?
Sin x is
Okay, no problem.
which, how do we know if it's increasing or decreasing?
Yes, that's the see. Okay, see, we have so many points discussing here. Okay, see, Rishit, let us suppose we have a function y is equals to fx. The meaning of increasing function is, if x increases, then y should also increase. That's the meaning of increasing function. If x decreases, what should be y? Y should also decrease.
Decrease.
That's the meaning of increasing. If x increases, then y increases. Let us suppose the very simple example is y is equals to x. When you see the graph of this y is equals to x, you will get this straight line. Sorry. You will get this straight line, right? As you can see, when your x is increasing, see, if you are increasing your x, you can see your y is also increasing, isn't it? Are you getting my point?
Oh, yeah, yeah.
If you are seeing in a negative direction, if you are seeing in reverse direction, it means you are seeing x decreasing, so y will also decreasing. Graph is same. So just it depend on your view. You are seeing x as increasing, then y should also increasing. If you are seeing x as decreasing, y should also be decreasing. Both case belongs to increasing function. Is it okay?
Yeah.
Similarly, for decreasing function, let me write. Similarly, for decreasing function, if let us suppose y is equals to fx is my function, if x increases, y should get decrease. If x decreases, y should get increase. That's the meaning of decreasing function, right? Okay. Okay, how to know any function is increasing or decreasing, or any function is increasing in which domain? For this you have studied in your calculus. What is the condition? Dy upon dx should be greater
Greater
than
than
0
zero.
for an increasing function, and dy upon dx should be less than 0 for an decreasing function. It means any function may be increasing also for any particular domain, or may be decreasing also for any particular domain, isn't it? Let us see what I'm saying. See, this y is equal to sine x. It is neither completely increasing, nor completely decreasing. In some range it is increasing, in some range, or you can say in some domain it is decreasing. Are you getting my point? See, a function may be completely increasing or may be completely decreasing. That's okay, that's fine. For example, if you have y is equals to y is equals to e raised to power x, it's completely increasing function. See, always increasing. There is no decreasing portion in this. Are you getting my point?
Yeah, okay.
But it may also possible that your function is increasing in some domain, decreasing in some domain. So you should have the idea. For example, now you know this is 90 degree, and this value is 1. This is 180 degree. This is 270 degree, and this is negative of 1, and this is 360 degree. Is it okay? Now, with the help of my given explanation, you can easily decode in which domain it's going to be increasing and in which domain it's going to be decreasing. Can you tell me from 0 to 90 degree? Can you study, is it increasing or
With
decreasing?
respect to
Yes.
increasing.
Yes, as your x is increasing, you can see your y is also increasing. Is it okay?
Yeah,
So
yeah.
for this domain 0 to 90 degree, your function is increasing. Now, can you tell me 90 to 180? What is happening in 90 to 180?
Decreasing.
It's an decreasing. Yes, your x is still increasing. See, your x is still increasing 92, but
Yeah, but
your
why
y
decreasing?
coordinate is going to be decreasing. So that's why it's a now I think it's very simple to find graphically how whether a function is increasing or decreasing in any particular domain. Is it okay?
Yes, yes.
Okay, now we are able to solve our question. See, now the question was fx is equals to this in this region. See, Still, this question can be solved with two methods. First method, which will include these concepts, whatever we have discussing right now, and the second is the graphical approach. See, you should have. Let me explain with the graphical approach. See, this is the graph of sin x. You should have the idea. This is the 0 degree. This is the 90 degree. This is the 180 degree. This is the 270 degree, and this is the 360 degree. Is it okay? Right.
Oh yeah.
We have to we are interested in 180 to 360 degree. Your viewing window, your view window is from 180 to 360. So just see only this portion of the graph and tell me what's the range. So its minimum value is lying, see, 0 to -1, isn't it? This value is what? -1. This value is minimum here 0. Its y coordinate is 0. Are you getting my point?
Yeah.
So the all function value is lying from 0 to -1, isn't it?
Yeah.
So your answer should be 0 to -1 if you have the this idea. Otherwise, you have to do the your inequality relation. If you are taking sine both side, then you have to see. Then you have to break the relation. See, 180 to 270 degree, it's decreasing. See, as your x is increasing, y is going to decrease. So from 180 to 270, it's a decreasing function. But 270 to 360 degree, as your x is increasing, now y is increasing. So here it's increasing function, here it's decreasing function. That will be complicated approach, but I think its graphical approach is very easy. Is it okay?
Oh yes, sir.
Okay. You are given that your gx is lying from 0 to 1. Work out the value of theta. Now, see, in the first part, you have the value of this. See, it's a very good question. See, in the first, for sin x, you have the domain value, that is the 180 to 360. Then you have find it its range, that it will lie from 0 to -1. Is it okay? Now, the second
Yeah.
part is saying you have given the range of this gx. Now we have the range of gx. Now I have to tell me what will be the domain value, what will be the domain for x. It means for which interval of x your gx will lie from 0 to 1. So lower limit is given, it's 0 degree, but its upper limit is still unknown. So you have to find the theta. Are you getting the question right now?
Yeah. So first we'll have to draw the cost graph.
Yes, that's so simple. You should approach with your graphical way. So plot the graph of cos x. See, so let me plot the graph of cos x. See, lower limit is given, that's a 0 degree. So just start from this, right? So this is 0, this is going to be 90, this is going to be 180, this is going to be 270, and this is going to be 360. Is it okay? Is there any problem in the graph of cos x?
No.
No. Now my range of gx is 0 to 1. Where is the 0? 0 here, 1 is here.
Is there, yeah.
So 0 to 1, 0 to 1, and my x start from 0. So 0 to 1, I think 0 to 90.
Yeah. Yeah.
Range, see, its range is 1 to 0, but you always write in an increasing manner. So my range will be 0 to 1. Are you getting my point? Is it okay?
So so is the answer 90?
90, yes, theta should be 90.
Okay. Okay.
Any problem?
No. So you just see like where 0 and 1, like where they or like where they meet, like the area between them, and then you
No,
see the value.
no, no, no. There is no concept of area here. You have to just
No, no, I'm just saying like the thing between them.
yes, yes, yes. So it's -1. Is it okay, Rishit?
Yeah, yeah.
Okay.